Hey everyone, Jared here. In the last video, I showed how to make a to-do list using HTML, CSS, and JavaScript. And the to-do app looked very nice and it had all the basic functionality that a to-do app should have. However, in this video, I want to show you a different way to build this app, a different paradigm, if you will, of how to code in JavaScript that is a little bit more realistic in regards to a potential full stack application. So this will be a nice stepping stone between building your first applications to building applications that actually have a backend involved. So without further ado, I'm going to share my screen. I'm going to get started right away with all that. So essentially, there's a new paradigm that we're going to learn here, and that is consider this scenario, right? At the moment, we have hard-coded all of our to-dos into our HTML. We have all these to-dos: complete online JavaScript course, jog around the park 3 times, etc., all hard-coded into our HTML. That means that if anybody around the world opened up our website, they would have all of these to-dos on their screen right away. And that's obviously not what we want because, when somebody theoretically creates an account for the first time, they shouldn't have any to-dos, right? They should be creating their own to-dos and everyone should be different. Therefore, we should actually start with none. So I'm going to remove all these to-dos. And now this is what the actual UI should look like when somebody just gets started with our app. Now, how, when they load our app for like the 10th time, will they see what they created, right? In the previous 9 times they used our app, they probably created some to-dos, marked some as complete and whatnot. So how, when they open their app the 10th time, will they have all the information about what happened the previous 9 times? Well, that's where a database comes into play. So right now, all we've done is front-end code, all visual code. However, realistically, an application will involve the front end and back end talking to each other, where the back end stores data that the user created, essentially. And the front end will ask the back end for data, the back end will send the data to the front end, and based on the data that the front end receives, it will generate the UI. So while we're not going to deal with the back end yet, what I will do is kind of show you what it's like from the point that the front end receives the data from the back end. So we're not going to get data from a back end, but we're going to simulate as if the front end has already gotten the data from the back end. And then from there on, we have to generate the UI out of that data that we received. I'm just going to save this up here for a second. So what data do we want in this app? We're basically assuming that this user created these 6 to-dos. So let's stick with that being the actual data that we have as our initial data for this user, theoretical user. So they have all these to-dos created already, and the first one has been completed. They marked it as completed. So actually, I'm going to need this. So I'm going to copy all of this because actually what I'm going to do is something a little nifty. I'm going to highlight span to do text. I'm going to Command D, or for Windows Control D, so I get all of them. Then I'm going to hit my cursor to the right, and actually this won't work perfectly, but I'll do my best. I will hit Option Shift, probably for Windows it'd be like Alt Shift or something, and then the right arrow, and that allows me to like copy multiple words. The longest one I have is like 5 words. Oh, I didn't capture all of them, so let me try that one more time. Gonna highlight this, Command D everything, right arrow, and then Option Shift right arrow until I've highlighted everything. Oh, this one's not highlighting for some reason. Why is that? Span to do, oh, that's better. Okay, so now it's not perfect, but anyway, I'm highlighting all of these guys so I can copy them and then paste them in my JavaScript because that's data that we're going to be using. Okay, so I kind of got them all in as easy a way as possible. Now I can delete all this stuff from my to-do container, so it's effectively empty, and we're going to basically insert items into the to-do container based on the data that we have for the to-dos. So we have to create a variable to store our to-dos data that we're going to create the UI out of. And all of these items are going to be part of our to-dos data. Each line effectively is a different to-do, right? And each to-do, we want to know, is it completed or not, right? The user is telling us, or when they're interacting with the application, they're marking it as active or completed. So we have to, in our database, theoretical database, we need to know and keep track of each to-do and if it has been completed or not. And of course, well, actually, what I was going to say is when the user deletes a to-do, we can assume that our database doesn't need that to-do anymore. And the reason I half smirked there is because you could theoretically keep track of the to-dos that they deleted in a database in case they want to see their deleted history. For example, on my and for like Mac and iPhone, when you delete a photo, it will actually keep the photo for 30 more days to ensure that you actually wanted it deleted. Otherwise, you have like 30 days to go back and save that photo before it officially gets removed, you know. So you don't actually have to, when you have a database for your application, you don't actually have to remove a to-do when it gets deleted. But, you know, to keep things simple for now, that's what we're going to assume. So therefore, all we have to know about every to-do is, you know, if we have a to-do, then it exists and we should be showing it. And so we just need to know the name of the to-do, like the text, and also the completed or not, right? So for every to-do, we're going to have text and we're going to have completed. So we're basically representing the data that matters in JavaScript. The text is going to be a string detailing whatever the user typed for that to do. And then the completed value will be true or false. It has been completed or not. That's all we need to know. There's only two states for a to-do. Either it's completed or it isn't. So when there's only two states for something, we can use a Boolean to represent one of those two states. So I'm just basically going to create an object for each to-do. So our to-dos data is a list of to-dos where each to-do is just an object. And by list, I mean array. They're almost interchangeable terms. So I'm just copying all of our to-dos in quickly. Now, the first ones are only true completed. Everything else has not been completed, meaning it's active, right? Where am I? Jog around park, 10 minutes meditation. Read for an hour. Pick up groceries. And complete to-do app. Okay. And I can get rid of these now. Okay, so this is our data. And right now it's empty. So we have to go from this array of objects to actually making a UI. And you should have gleaned enough about DOM manipulation by now to realize that you can create DOM elements in JavaScript, right? That's what DOM manipulation can do. You can document.createElement, a div, you can give it and store that in a variable. Let's call it a new to-do, right? We're creating a new to-do. So we wrote a function for this before, right? To make a to-do, we create a div, we add the class to-do. Of course, we added bar as well, so I'll just add both, of course. Now we also have to consider, is this to-do going to be completed or not, right? We'll get there actually, but I just wanted to remind you, yes, like you can create a new div and then stick it into the to-do container, right? You say to-do container, which we have already gotten up here, right there, dot append or prepend, so prepend our new to-do, right? And we assume that, you know, we stick a lot of info in the new to-do, right? Element. So we just have to figure out what to stick in there, and it's going to be based on the data. Now, this is an array of objects. So for each object, hint, hint, for each, object, we want to create a to-do UI, right? A to-do component in the UI. So all we have to do is do to-dos data dot for each. And then for each to-do data, we will somehow we will make a to-do of some, and we'll pass in the to-do data. So using the to-do data object, basically. So when I do for each over to-dos data, then to-do data represents one object at a time. So this object, then the next iteration, it's this object, then the next iteration, it's this object, and so on. Every object has the same properties, text and completed. Therefore, when we make it to do, we are going to stick the info in the new to do, and its completed property will tell us should we add the class completed or not, and the text will tell us exactly what to put inside of this span called to do text. So I think I've explained that as much as I possibly can, so it's time to see this in action. I won't make that function make to do yet. I'll bring it out in a moment. But for now, let's just do the actual lines of code right here that we need. So basically, oh, look at that. Already, for each to-do data, for each item inside the to-dos data array, so there should be 6 of them, we have basically created a div with classes bar and to-do, and then stuck it in the to-do container. And as you can see, there are 6 bars here that are stuck inside the to-do container. Of course, there's nothing inside those bars, but inherently these two classes give these bars a little bit of UI, a little bit of padding, some border or whatever I have by default under the bar class and the to-do class. But of course, we want to populate it with all the stuff that we care about. So finally, we have to, first of all, we consider while we're adding classes here, we want to consider, are we adding the completed class or not? So all we have to do is check, is this to-do data object, is its completed property true or false? So we say if its to-do data, sorry, if its completed property is true, then we new to do dot class list dot add completed. Otherwise, we don't even add the class completed. And we have to do it now, add all of the stuff inside. So we have to do inner HTML equals, and then those backticks so that we can insert JavaScript, because the JavaScript we're going to use is the text property of the to-do data object. So the inner HTML that we want to add, just like before, is all this stuff. And I don't like the indentation. So let's see, don't like the way they format things by default. This is not effectively changing any logic, just the organization. There we go. So basically, now we have 6 items, but all of them have the same text, except one of them is completed. They're in the wrong order because we start with this one and it's completed. So therefore, that's the crossed out one. And then we do prepend. So that sticks the next guys on top, right? So actually, it's just an effect of like the order of the array versus the idea that we're prepending. If we append, then we're going to preserve the order. So we actually want that if we're going to match our UI here. So to do container append. Okay, so now we have the same text for everything, right? So we have to make the text variable. So we just need, instead of hard coding the text that goes inside the to-do text span, we need to use to-do data dot text. And now we have recreated our UI again, just using this approach where the data has been given to us. We're assuming that this data came from somewhere. So realistically, we would have had a function called getData that asks database for data, and then to-dos data will be the result of that. So it would really be like let to-dos data equal an empty array, and then we run this function get to-dos, or actually we don't need that initial part. you would just say let todos data equal get data. And get data function, the get data function will do all the logic associated with asking our database for data. And then once we have the to-dos data, then everything else we're about to write can happen. So we're just assuming that all of this has been done. Now in a future video, I can talk about what it's like to get data. In this video, we're not there yet. So we're just assuming that we've been given all this data at this point. And this is our initial data to start with effectively. So let's test our application now. We just rewrote how our application populates. And it looks like it's working okay. This isn't working. This isn't working. Why aren't these working, but this one is? Well, if you recall, we wrote, and I can get rid of this. If you recall, we had an event listener to act when we click on a to-do. And what it will do is toggle completed. It'll update the items left, right? And it will disappear effectively if we're on a certain filter. Now, this is working for new ones we create, right? And that is because when we create a new one, we still have this event listener submit on the form firing and creating a new to-do element, and on that new to-do element, we add an event listener, right? So we actually, because we've changed the way that we're rendering our initial to-dos, we did not yet add this event listener. That's why they're not working right now for the initial to-dos that we've hard-coded in our data up here. So last, before appending or after, doesn't matter, you can do new to-do add event listener, click, and then we run the to-do handler, passing in the event, the click event, and also the new to-do itself. And now these guys are clickable. And just like that, I think our application will be exactly the same. So we have not done much, but we have changed the paradigm a little bit with how we run the generation of the UI for this application, right? It's more JavaScript centric. It comes more from data that's given to us as opposed to hard coding the data ourselves. When we hard code the data, it can't vary based on different people, right? We need data to be given to us. So I want to continue this data first idea where the data determines what the UI will be. The UI will effectively look almost the same, like all the divs and class names and everything will be the same, but they'll just change in terms of quantity and what's inside of each of them as far as the text inside of everything based on data. And I want to basically change the paradigm of this program. The way I'm going to change the paradigm in this program, it's going to resemble the thought process with how you code in React. So what I'm about to do is going to be a really interesting stepping stone in your mind of how to make a program that will lead you to thinking in the React way better. And I do recommend you learn React after being familiar with making front ends with normal JavaScript. So we're trying to like stepping stone get you there. So just like, so let's say that this to-dos data object is really important to us. Actually, let me rephrase here. What I want to introduce to you is the concept called state. Application state is a very important concept in React, which is why this way of thinking is going to help you when you get to React. But the state of an application is a certain way of thinking about an application that helps you kind of organize your logic with how the application will change as the user interacts with it. So our application is very simple right now, but I'll hopefully be able to come up with examples of how it can get more complicated, and therefore application state will become more beneficial. So what is this state idea I'm talking about? Well, it is a different pattern and way of thinking to, rather than just put things in the UI and when the user clicks stuff, react, make the UI change based on like what's currently in the UI. Like for example, when I change the filter, I am grabbing all of the guys in the to-do list, and I am taking out the to-dos that were marked as completed, right? So when the user does something, we're taking account of what is on the screen and then acting accordingly based on what's on the screen. What if we instead record in JavaScript what the screen looks like currently and what it should look like when the user does things? So just in this example, we've recorded what data the user should have on it. And then with that data, we populated the UI. And now, whenever we, let's say, click a to-do, we will see, okay, is that to-do's completed property false or true? And if it's true, then we'll change it to false and then update the UI accordingly. So basically, we're using the data as the source of truth for our application, as our application state. And using that state, it will describe how the UI looks. It's just in a data format. What this will do is simplify how we create changes in our UI. And so let's work on some of the features on how to do that. So, dark and light mode we don't have to concern ourselves with at the moment. However, I will say that, you could just write your application to be light mode by default or to inherently use whatever the user's setting for their computer is on. Like if their setting is on dark mode, you can have your application inherit the fact that they're on dark mode, so you do dark mode. Or you can by default always be light mode and then make them change. Or you can have your application, when you have a backend, store their preferences so that whenever they load the app, you check the database for their preferences that you've stored. And if they prefer dark mode, that it's dark mode by default. If that's the case, then we can actually hard code that as well. And let's say we start with const mode, or theme rather is a better word, is light mode, right? So if the theme that comes from the database from regarding the user's preference is light mode, then in JavaScript we can say what the body's class name should be, right? By default we wrote light theme, but what if we gave it no default? And then or we don't even write that. And then only in JavaScript we say, okay, if the theme is light mode, then we make the body class body dot document dot body dot class list dot add light mode. I should say equals is better. Dot class name equals light mode, else the document body class name equals dark mode. So if I change this, assuming that this variable came from the database, then why didn't that work? Dark mode. The theme, dark mode, light mode. Just make sure my JavaScript is updating. It is. So this didn't work for some reason. We have const theme is dark mode. If the theme is light mode, then we make the body class name light mode. Otherwise, we make it dark mode. Ah, shoot. I think it should be theme, right? My bad. So basically, like, this looks silly right now because we're just making a variable then checking against it. But if we had a function called getTheme from database, and this did a bunch of stuff to gets contacts database asking for a theme and receives the theme, then the receive theme was light theme, then we return the received theme. Then this looks a little bit more interesting, right? So the theme that we're going to use is going to get theme from the database, right? And that's going to return to us whatever we got from the database. So if we got from the database dark theme, then, we will basically when our application runs, we'll get the theme from the database and using whatever came back from the database, update the document body's class name accordingly. So again, we're using a data first approach to generating our UI. So now let's and now of course this still works as well. So let's just stick with light theme for now. It doesn't really matter. And let's do some more of these features with this data first approach. At the end of this video, I will show, well, I'll explain why this isn't the best approach necessarily for vanilla JavaScript, but it is very applicable, this way of thinking, to React, where it will fill in the issues that that I will explain that are associated with the vanilla JavaScript approach. So don't worry about that for now. We're just going to rewrite our application basically in order to achieve the same stuff that we have done already. I'm actually just going to comment all this stuff that we did and just grab whatever I need when I need it. So let's just go through our list of functionality again. And we want to now create, actually, let me make sure that the light mode and dark mode is changing. It probably isn't. Well, actually, this is a really easy one to write in this data first approach. So let's say that I wanted to keep track of the theme in JavaScript. And so whenever the user clicks to change the theme, we update the JavaScript variable that's storing what the theme should be. And then we update the DOM dependent on that variable. So the variable, or in essence, the data holding the theme that the user should see is our source of truth that we're updating the UI based upon. So currently, the theme is light theme. But when we click this guy, we want to change to dark theme, right? So this guy is the mode icon. So again, we're going to add event listener and listen for clicks and run a function with an event. And when that click happens, we're going to change the mode, the theme. I should call it theme icon, not mode icon, now that I think about it, but that's okay. So I'm going to now change the theme. So I'm going to say if theme, and I can't say const because I'm going to update its value. So I say let theme, and I say if the theme is equal to light theme, then the theme will become dark theme. Else it will become light theme, because that means it's currently dark theme. And not only do I have to change the theme, but now I have to change the document body class name to be equal to the current theme. So basically I change the theme and then I update the UI based on that new theme. So we still have, if the theme is light theme, then it's dark theme. Else, whoops, theme equals light theme. Okay, so now we've achieved the same thing, but we're just using this theme variable as our state for the application. So if we ever want to know what does the application look like right now, what should it look like? What data is important for this application right now? This theme variable has the information for the theme. That doesn't look like very much, but now let's take in the data into account and we'll see that the way of programming everything that we accomplished before will be much different. So first we create a new to-do. So where is our form submit? So I'm just going to copy this and then remove some stuff that we don't need. So when we create a to-do, so our to-do form, when we submit, we run a function, we prevent the default behavior. Now I'm going to take out pretty much everything here. I will keep the reset because we're going to want to clear when we're done with with adding a new to-do. But you'll see how cool this is. We want a new to-do to go to the top, right? So we have to-dos data, and the order matters here, right? We have the order of to-dos, and we're basically rendering them in order, right? That's what we do initially. What if all we have to do in order to change our list, why is everything empty? Did I comment stuff out? Oops. Oh, I didn't mean to comment this out. My bad. Okay, sorry. What if when we created to do a new to do, all I have to do is change the data array of objects and add a new object in there at the very beginning, so it will get rendered first and then everything else below it. And then I just re-render the entire to-do list all over again. There's pros and cons to that, but the logic for it will look very simple. So we're sticking with the pros for now. And we're just coding this application in this other way, just so I can show you, because this will be the way you kind of do things in React, and it won't have the downsides that I'll explain that this approach does have with vanilla JavaScript. The application as we had it just before we commented all this stuff out was perfectly acceptable for vanilla JavaScript, just so you know. But okay, so the logic is very simple. If I want to create a to-do, if all I have to do is stick an item in and then re-render everything. So I'm going to do just that, and in my to-dos data, I'm going to unshift will stick an item at the beginning, not at the end. At the end, I do push.push, but at the beginning, I do unshift, and I'm adding in an object that will have text and completed. Now, a new object will not be completed yet, so completed will be false, a new to-do, rather. And then the text will be whatever the form input had in it. So we grab this stuff as well. So we say, okay, the new to-do text is the new to-do text input, which we grab from the DOM, dot value. And that's what the text that the user typed is. We just check if the text has any length at all after being trimmed for all white space. And then if there is length to the text that has been typed, we create a new to-do in a new to-do object, if you will, in our to-dos data. And now we have to render again. So I'm going to create, I won't create a function just yet. I will actually. Where is my code here? So this is the information regarding what to do when we are creating our to-dos, right? So I need this same logic when, so basically I'm just copying this stuff in, then I'll analyze what's going on. So we add a new object to our to-dos data. So now our to-dos data is different, and we want to completely re-render this all over again. So I have to clear it first. I say to-do container.inner HTML equals an empty string. So there's no longer anything here. So let me just comment out all this so you can see what that means. So that means when I submit this form, I clear all the to-do items. So that's where we are at this point. But now I would like to again go through all of the items. Oh, actually, this isn't even what I should have copied. I need to go through all of the to-dos data, which is now new. To-dos data is now new because I've added something in it. So it's different now. And then for each of them, I go in and I stick new to-dos back in the container again. Oops. So this is our initial data. Then I add, boom. Oh, to-do data. Okay, almost there. So first, just to recap one more time, I added an object into the to-dos data, and then I'm trying to loop over the new to-dos data, which now has 7 items instead of 6, and for each of them, generate the UI for a to-do and stick it in the UI in the to-do container. The problem is the one I just created, there's no text here. There should be a to-do data.text. Actually, why did that not work? Because I didn't write any text. I have to put the new to-do text into the text property for the object that I'm adding to my to-dos data. So let me try that one more time now. And there we go. Our app is adding to-dos. Now it appears that when I click, this isn't working, and that is because we have no logic anymore. We've commented it out for what happens when I click to-dos. So we'll get to that next. But at the moment, creating new to-dos is now working, and it's in a different approach. And now what I can do is actually look at the code that I have here and here. It's exactly the same, right? This is for the initial generation of the UI based on the data we got from the database. Assuming we have data in the database, data comes back, we initially show it in the UI, and then we do the same exact logic again when we update the amount of data we have, basically. So I can put all this in a function and call it, let's say, render to-dos from data. I don't know. Just render to-dos is fine. And I'm going to just copy all this logic into here. And now I can call render to-dos right here. And I think that should be okay. Now, even though our to-dos data by default has stuff in it, now that we have put this logic into a function, on the initial run of our JavaScript, we are never actually executing this line of code because we've wrapped it in a function. So we've created the function, but we're not running the function. So we have to run it right there. So now our initial thing is as it should be, and now adding is working. Now, what you'll see is now that we have this data as our source of truth, all we have to do whenever we want to update anything in the UI is just update this data here and then run this function again, render to-dos, and it will re-render all the to-dos all over again. So why don't we work on the next one, which is toggling to-dos as completed or not completed. So I needed an event listener when I click any to-do, correct? So I still need a to-do click handler. And so let's define what happens when I click a to-do now using this new model. I actually will not need to do that. You'll see why, and I'll compare side by side. So when I click a to-do, I essentially need to take a look at the object representing that to-do and see if its completed property is true or false and change it to the opposite. That's all I have to do, and then we will just re-render the to-dos all over again. Remember, oh, one thing I forgot to put in render to-dos is this to-do container.innerHTML equals empty string. Because whenever we're rendering the to-dos, we just basically get rid of everything and then re-render it all over again. So I can put that logic directly in the function responsible for rendering the to-dos. And of course, on the initial run, this line will do nothing because it's inner HTML. Where is it? To do container is initially empty, so its inner HTML is already empty, but this line will just do nothing on the first run. So to do click handler. When we click a to do, we need to basically access its object in the to-dos data and change its completed property to whatever the opposite of it that it currently is. So we have the to-do, and what we can do to identify which object is the correct one, right, is use its text. Its text will tell us how, like this object is different from this object, right? The text is what's unique to every object. Now you could have an issue where you have two objects with the same name, right? What if we had two? Whether the user intended this or not, but they may intend it for whatever reason to have two with the exact same name, right? What if they had two of these? Well, then we have a little issue, right? What if one's true, one's false? And, we click one and we want to change its completed property. Because what we're changing is actually this data object, we're not exactly linked to what we're clicking. We have to, with logic, link what we're clicking with what's in the data, right? We're not clicking this data array of objects necessarily. We're clicking the DOM element. And before we were just changing the DOM element properties, but now we're using data as a source of truth. So we have to associate whatever we clicked with one of the objects in this data. So we have an issue when we have more than one with the same properties, basically. And it's hard to identify which one we actually clicked in this list because we could only click one. So what we actually, what you'll learn is with databases, every thing that gets stored in the database will have an identifier, for short ID, and it will look like a bunch of gibberish basically, and it will be unique for every single thing stored in the database because everything that's stored in the database needs to be identifiable, where all of its other properties could be the same as another item in the database, and if that's the case, they become impossible to distinguish. The ID is the distinguisher, basically. It will always be unique. So that's how we can always identify what object is what, basically. And these objects, again, came from our database. So what to use for an ID? People will simply use like ID equals 1 as a number, and then ID equals 2. But that's not like what it really looks like in application. It will actually look like this. UUID stands for I'll get the exact acronym. Universally unique identifier. And they look like this, kind of. So it's just like a long string of a bunch of characters, effectively. So I'm going to import a function that I got from ChatGPT for generating one. When you're further along in JavaScript, you can actually import code that other people have written. This is what's called libraries. You can import code that other people wrote and use that code directly in your project. But I don't want to get onto too many topics. So for now, I'm going to grab the function wherever it is. That's in this one. For generating a UUID, a unique identifier. So this function I'm going to call every time I want to generate a unique identifier. So I'm going to do that for every of these objects. And we're going to use the ID to identify all these objects from each other. When I create a new to-do, I also need to generate an ID as well. And what we need to do as well is have all of our DOM elements have an ID property. So every one of these to-dos will have an ID now that we can use to identify it and match it with the IDs that are in our data, our to-dos data. So basically, whenever we're creating our to-dos, remember, we're creating our to-dos in the DOM from the data objects that we already have. And those data objects have the ID property. So when we're rendering our to-dos, our to-do, we can give an ID equal, and I'll put it up here, the new to-do ID will equal the to-do data dot ID. So now let's take a look at our information, our data here, our elements. And we see that every to-do has an ID now. They also have the classes bar and to-do and completed, or it doesn't have the class completed, but everything has the ID. And they're all unique IDs, you see. And so whenever I click on one of these guys, I can be like, okay, this one I clicked on has this ID, and I can correspond that with an object in our to-dos data. So let's do that now. For every to-do, to-dos, we're going to, for each of them, to do dot add event listener for click function. How am I doing here? So when I click a to do, I would like to run the to do click handler function, passing in the event and the to do, just like we were doing before. Now the to do click handler, now that we have the event and the to do in this function, the to do dot ID we will use to match a to do data dot ID. But we have to loop through all the to do data and figure out which object in that array has the correct ID, and that's the object that we're going to update. So we have to do to do's data, which is our array of objects, dot, we can actually find, there's a property find. We could use filter, but we're going to use find because it's a little bit more specific to what we're trying to do. We're trying to find which object or which item in to do's data will match a certain statement. So for each to do data, we are going to look for where the to do data dot ID is equal to the to do dot ID. And that is going to be our clicked to do. Const should be appropriate here, clicked to do, and that's the one that we clicked. Well, I shouldn't say click to do because I'm talking about to do's data. Clicked to do, click to do is okay. So the click to do, I'll click to do data. So the data for the click to do. And what I have to do is change its completed property to be what its current completed property is not. So that is me flipping its completed property. And then once I've done that, I just have to re-render the UI again with the function that we had called render to-dos. So now let's try. And as you can see, the toggling is working. Why is this again? Because we find, when we click a to do, we find which object in this array corresponds with the item that was clicked via its ID. And then we change its completed property from true or false, or from false to true. And then we re-render all of these guys all over again. So the only one that actually changed is the one we clicked on, but we do actually remove everything and replace them all over again. Okay, so that is creating a new, that's toggling to-dos. Now we have to do deleting to-dos. So hopefully you can start understanding the pattern here. The pattern will now be when I click a to-do to find out which, or to basically, when I click a to-do, I have to remove which one of these has the ID of the thing that was clicked. So when I click a to-do, or when I click, I need to do click handlers for the delete buttons now. And for each delete button, I'm going to run a function that will basically, again, we need the, well, we're going to need the ID of the to-do that got clicked. So I actually want to restructure my code a little bit right now. Remember that we talked before that when I click this guy, I'm not only clicking the delete button, but I'm also clicking the to-do because the delete button is inside the to-do, and both the delete button and the to-do have click event listeners. So I can actually put the event listener for the delete buttons inside my code for the to-do event listening. So when I listen for an event, on the to-do for a click, I can first check if the event.target was specifically the delete button or not. So remember, when I click on the delete button, I'm just going to freeze this because it's in hover. When I click on this delete button, I'm always going to either be clicking this image or this span, right? It's hard to distinguish which one. It could be either. And I forgot, well, I never had to, but for this approach, I'm going to give these images a class as well. So let me just do that real quick. So I'm going to give all the images that we create for this delete button, I'm going to give them the class delete image. So now, when I'm going to comment that out, and so, okay, when a to-do is clicked, I'm going to first check if the event.target.class list.contains either delete button or all this but delete image. So now I'm checking, did the thing I clicked contain one of these two classes that would indicate that I clicked the delete button? If so, I'm going to delete the to-do. Otherwise, I'm going to do the to-do click handler, which doesn't seem so appropriate anymore, but I can modify this later, or I'll actually modify this quite soon. But what I want to happen, let me take this logic here. So forget the to-do click handler for a moment. If I've not clicked the delete button or the delete image, that means I'm just toggling. So in that case, I am just going to toggle the completed information about the to-do that I just clicked and then render the to-dos all over again. This, however, if I did click the delete button or delete image, then I can do some different logic that will effectively delete the to-do from our array of objects. And then when we re-render the list again, that object will no longer exist. So inherently, that thing will be removed from the UI. So what we do is we say to-dos data dot find, well, actually, in this case, we want the to-dos data to be replaced, and we're going to replace it with filtering out the to-do item that was just clicked. So basically, if the to-do data.id is equal to the event, we don't want event target ID, we want the click to do data. So actually, let's see, we get the clicked to do, I don't want the click to do data, I want the, yes, to do. I need the to do. The to-do.id. So the to-do's ID that was clicked, if it matches the to-do data ID as I'm looping through all of our to-do data objects, then that is what we want to filter out. So basically, the to-do's data will get replaced with what it currently is, but filtering out basically when the to-do data ID matches what just got clicked. So basically we are keeping everything where the ID doesn't match. Now in both of these scenarios, I need to render the to-dos again. So I'm sticking that outside of the if clause because both of them are going to do this after all their other logic happens. So let's see if everything is working. The toggling is working and deleting is not. Let's check why. We want to console log our event.target. Let's see what we're getting here. We are not getting anything. That is weird. Where are other event listeners here? Here. Okay, yeah. So I was writing for each. I forget what I was doing here, but this is the logic that we are going to want to run every time a to-do gets clicked. So this is actually going to be the new logic for, let me just keep that down there for a second, for this is going to be the logic for, where's our function? To do click handler instead. So before we were just doing the toggling, but now our to do click handler is going to handle clicks on to do and specifically clicks on the deleting button. So now we just need to use this to do click handler whenever we create a new to do, as we were doing there. And also initially when we have our to-dos up front, we want to add the event listener that calls our to-do click handler and passes in the event and the to-do. And let's see how we're doing now. Okay, that didn't work. I'm using a const variable somewhere I should not. Not that one. Line 125. To-dos data. We have to do let because I'm resetting the value of to-dos data later in my code. Okay, now it is working. Cool. So our click handler is now working. We are using the data here as a source of truth and then updating the UI based on the data that we have just changed in the to-dos data. Okay, so that is deleting, and now we want to clear the completed to-dos by clicking clear completed. So we need a event listener on clear completed. Clear completed button dot add event listener for click, and we run function event. So when we click that, now instead of going to the UI and seeing which ones have the class completed, instead we go to our to-dos data and we filter out the ones that have the class completed. So basically we say to-dos data, the to-dos data dot filter, the to-do data where the completed is false. That's all we want, is where the to-do completed is false. So now if I clear completed, we just theoretically will just be keeping the to-dos where the to-do data dot completed is false. Yeah, if the to-do data is completed is false, then we want to keep it. Okay, something's not working yet, but let me get rid of that console log because it's bothering me. Okay, let me figure out what's happening. So first of all, let's just console log something so we know that this event listener is even firing. And it is. So now I would like to console log to do data.completed triple equals false to make sure that I'm thinking about this correctly. And so this is going to console log for every to do data. So there's the something we don't need anymore. Then true, false, true, 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 true. So if it's equal to false. So yeah, we should have this one, not this one, this one, this one, this one, this one, this one. Oh, I was forgetting to render the to-dos again. Silly me. So now it should work. So we update first the data, and then we render the UI all over again. There we go. So now it's working. And just to check, actually, I don't think I've done the filters now, so I don't think that will work. Yeah, filters aren't done yet. Okay, so I can take out that console log and everything is fine. If I wanted to shorten this even more, I could just say not to do data.completed, and that will have the same effect. Because to do data.completed, will return true if it's true, and if it's false, then not false would be true. So we basically want when false will lead us to true. That's confusing. You can keep this logic and it's perfectly fine if it's more easy to understand. Okay, so that is clearing the completed. Now we have to calculate items left, and we will have to do every time we render the to-dos, right? Um, I don't know if it's, I think we should have a function that's separate though. So let's do a function called items left, update items left. And basically, we just need to grab how many items in our to-dos data that aren't completed, right? So we just need to return to-dos data dot filter each for completed being false again. And then we want the length of that. So basically the length of the array that we get when we filter to-dos data for just the to-dos where it's not completed. And that will give us our items left. And I want to change the UI. So I have to items left placeholder dot inner text equals items left. And now I think we should get it. Of course, we also have to run this function initially. So where's my initial code? See, this is the benefit of putting initial code at the bottom. Okay, so 6 items left, 1, 2, 3, 4, 5, 6. So that's what we expect. So we now want to update items left whenever we toggle. So that's when we click it to do. In fact, we want to, whenever we click it to do, whether we're toggling or deleting, we will want to update the items left again. So 5, 6, 7, 6. So that's working, and deleting is also changing things. So if I have it off and I delete, it should still say 4, and it does. So that is working, and now we are finally onto the last one, which is filtering the list when we go to active or completed. Okay, so all we have to do now is make our filters work. So let's just stick with the approach we've been using of storing data in our JavaScript and then using that data to generate the UI. So rather than hard coding the fact that, well, I don't mind calling selected on all first because I think it's okay as a default to just have that one be the selected filter, you know? Well, let me think. So I'll create a variable called selected filter, and I will say it is all. Now the selected filter values can be all, active, or completed. Those are the 3 possible values, right? So at the moment it's all, and we will see how this goes. So what I have to do, again, let me just do this at the bottom, just to be easier. So I need to set an event listener on all my filters as before. Add event listener. On click, I want to run a function. And so what do we want to happen? When, let's say we click on active, we would like to just show the items that are active. So we will have to filter to-dos data, but not, we don't want to modify to-dos data itself. We basically just want to take out part of it, like a copy of the part of it we care about, and put that in our UI, but we want to leave the actual data untouched. If we legitimately remove or exclude completed tasks when we click on active, then and this array of objects will have no longer have certain objects in it, then even if we click back to all, that object will be gone forever, theoretically. So we should not be modifying to-dos data because by clicking active or completed, we're not actually deleting anything. We're just filtering for part of the data that we want to see. So that's the goal. Right, so in render to-dos right now, what we're doing is simply removing everything from the to-do container and then adding in all the to-dos from our to-do list. At the moment, this function is not taking into account the filter that is currently active, but it should. So I'm going to actually move this up here so it's a little closer. So the selected filter actually becomes important. What we want to do is use to-dos data as a whole if the filter is all, right? But if the filter is active, we don't want to loop through every single to-dos data and render everything. So we have to do some kind of if conditions here. So we say, if the selected filter is active, let's say, then we would like to do not to-dos data for each, but to-dos data dot filter the to-do data for, I'm just going to write an error, no, I'm not. Function, I know I've done some already. To-do data. I'm going to filter for to-do data that it's completed. It's not completed, right? That's our active to-dos. So if the selected filter is active, our to-dos data dot filter will give us the to-dos data for which the to-do data is not completed. And then with that, we want to, for each, do all of this stuff. So I can actually extract all of this stuff because all this stuff will be the same regardless of what filter we want. All this stuff is just concerned with actually putting things into the UI. So let's see. I'll create a function here called make to do, make to-dos rather, and it'll pass in all of the data for all the to-dos that we want to, let's say, display to-dos. So we just pass in all the data that we want to display. So in our original case, let's make sure that we can get that to work properly before we start messing with filters. I basically want to, instead of doing all this here, I'm going to copy that into there. And in this, I'm instead going to call display to-dos and pass in to-dos data, where to-dos data, oops, what's going on? Don't need that. Filters that add on this. Just close that for a second. It's nothing, no errors. So, okay, that worked because I'm clearing the to-do container and then I'm displaying all the to-dos and I'm passing in this whole thing as my to-dos data. And that's okay because by default we're on the all filter. However, we want to consider which filter is selected now. So now that we've, yeah, I'm going to just write my if statements first so they're in place. So I'm going to do a case if the selected filter is active, if it's completed, and if it's else. What's the issue here? Display to-dos data. What's wrong? If, else if. Okay, so if the selected filter is active, we're going to do something. If it's completed, we're going to do something. Otherwise, that means we're on all. And in that case, we're just going to display to-dos of to-dos data. If we are not on, if we're on active, we instead would like to filter our to-dos data for our active data, let's say, active to-dos. And then we're going to display to-dos for our active to-dos. And we're going to do the same for completed. Completed to-dos, and we're going to filter for when the to-do data is completed. and we'll just test how this goes. Okay, so far nothing happens because when we render to-dos, the only time we're calling this function is the only time that we are running render to-dos right now, or essentially we are not currently doing anything when we click these, right? Our event listeners have not been set yet. So obviously nothing's happening. So what we have to do when we click a filter is change the selected filter, because render to-dos is going to take the selected filter into account. So we need to get the event.target.innerText, that dot to lowercase, that's going to be our clicked filter. And our clicked filter we're going to use to set the selected filter. Selected filter is equal, selected filter equals click filter. So we actually could just write up here, selected filter equals blah, blah, blah. Don't need this line. So we're setting our selected filter equal to the filter that was clicked. And then now that our filter has changed, we're going to actually want to re-render the to-dos again. Now filters dot, I need to do a dot for each, my bad. For each filter, function filter, we're going to add the event listener on the filter. Okay, so now when I click active, it appears to be working. Of course, what we can do before doing anything is checking if the selected filter matches already. In that case, we don't have to re-render our to-dos, right? Because we're going to get the exact same thing. So I will check. Okay, now I'll use this variable called clicked filter. So the filter that was clicked, we determine, and then we check if the clicked filter is already the selected filter, then we don't do anything. So we only do something if the clicked filter is not the currently selected filter, and that's when we'll re-render our to-dos all over again. Okay, now it's not working. Why is that? Let's debug. We want, oh, I forgot to also set the selected filter to the new clicked filter. So now this appears to be working properly. Of course, we also want the UI to change, so let's sort that out. We also want a function. Okay, so selected filter. Okay, so let's do this with JavaScript instead of doing any DOM manipulation. So let's just assume that all the filters, actually I don't have a problem with keeping that. What I'm basically going to do is have a function called update filter UI, just like before. And what it's going to do is take into account which of the filters is currently selected, and then based on that, give one filter the selected, that filter the selected class, and all the other ones not the selected class. That's what I did before, actually. So I will say filters dot for each filter. If the filter dot innerText dot to lowercase is equal to the current selected filter, then it's going to get the class name selected. Otherwise, actually, it should, yeah, gets the class list selected, gets the class selected. Otherwise, we remove the class selected. So we have to do that every time we click a filter. So we will only do that if we're clicking a new filter. So now the filter UIs are changing. Now, last thing we have to check is the last thing I mentioned in the previous video, which is that we need to make sure that when I'm inactive and I click, that the item disappears, or when I'm incompleted and I click, the item disappears because it no longer belongs in that category. And if I'm incompleted and I create a new to-do, that it does not appear here. So let's first start with active and just click one and see what happens. Okay, that worked. I do still have two items with the exact same name, which could be confusing, but let me click a different one. What am I doing? Okay, hold on. Let me refresh. Um, okay, and let me clear that guy because it's annoying. All right, cool. So if I go to completed and then I click, it's gone, but I still have now I have 6 items left, which is what I want. And here are my 6 items. And all or active is the same. If I'm inactive and I click, I no longer see that item, it's incompleted. So that is good. And what happens when I create a new to-do? It doesn't appear incompleted, but it is inactive and all. So I have successfully now created the exact same app using this data approach. And if you notice, this last bit here was really easy. And that is because we are using the data in order to generate the UI, and that's why it works so easily. Um, Basically, our data is our source of truth. So every time we refresh this list here, it takes into account all this data here, what the text and completed are for each object, how many objects there are and everything. And it also takes into account what the selected filter is, wherever it is. Selected filter. It takes into account the selected filter as well. So we already have all that information up front, and we just generate the UI based on all that information. And that is, in a way, easier to dissect when we have a much more complex application. Figuring out where things are going wrong is almost a little bit easier because it's just easier to trace the logic. When you are updating the UI directly in JavaScript, there might be a lot of things happening when things get clicked. And so the logic will just look a little uglier. Like, yeah, let's grab all these and let's filter out the ones that don't have this class name. It's just a little bit more ugly, like determining things based on their class names and stuff, as opposed to like having nicely organized objects with the properties that really matter right there for you. So hopefully that made sense. And I'd be curious to compare. Actually, here we go. Let's compare how long this code is, just out of curiosity. Um, this one starts, so all these lines are the same. So we start at about here and we go from 11 to 190. And then this one, so that's about 180 lines of code. This one starts at 192, goes to 322. So that's 130 lines of code. So this is a little bit longer, as I expected, the vanilla JavaScript approach of just using the UI and determining what's happening on the UI with the UI itself effectively. Not that the code is fully optimized in either method, but hopefully you can see like the nice organization of this one, where um, the data is very simple. It's a very simple flow. Like you just update the data with whatever you want to change in your app, and then you just re-render the UI again. So I want to close with just explaining why this approach isn't perfect when we're using just vanilla JavaScript. Basically, two of the main reasons, there may be more, but two of them are this one's less important, but rendering cost. By that, what I mean is like if we keep re-rendering the list of to-dos, that's just more work for the browser to have to like remove all these items and then repaint them again. Before we were just inserting like one thing or removing one thing or updating one thing. And theoretically, that's less work for the browser to do. So in that sense, the other approach is a little bit more optimized. And also for animating purposes, if you get to the point where you want to animate the insertion or deletion of items, it's actually kind of difficult in this HTML, CSS, JavaScript world to animate things entering and leaving the DOM. It's much more easy to animate things that are currently in the DOM and are just being changed. So in the other approach, we're like modifying things that are on the screen and we're not removing them and then replacing them. Remember, in this approach, we're completely removing and then completely replacing all the to-do items. So it's going to be difficult to animate the removal and addition of these items. However, I still wanted to show you this approach because it's more organized. And when you get to React, this is what the approach will look like. The issues of rendering cost and animation are actually not an issue in React. React has a way to do animating just as well as anything you can do with vanilla JavaScript and CSS. And it has a way as well to only re-render certain things. Like the way that you write the code, it's almost as if you are declaring like this is all the stuff that should be there. So like make it happen, and you think, oh, React's gonna, you know, cause make the UI like remove everything and then replace everything. But what React actually will do is just change the things that actually have to change. So that problem goes away with React. So the best approach was actually what we had before, which was a combination, because we do have to take into account that the data came from somewhere. So we have to store the data that matters in effective, which is effectively the to-do data. We have to store that data in a variable in JavaScript and generate the UI based on that data. But we didn't have to do all of the updating necessarily by modifying that array of objects and then re-rendering the entire list again. We could have, from there, just modified the UI itself, and that's okay. But both of these approaches actually in video 1 and 2 are not sufficient in general because we don't have a database yet. So in a real world, there will be a database that when we are deleting or creating or updating to-dos, we're actually sending information to the database, right? We're telling it remove this item or add this item or update the properties of this other item. So I'm going to make one more video that is going to make this as realistic as possible, and you can effectively make sort of full stack applications just using front end. So anyway, that's the end of this video. I hope you liked it. I know it was another long one, but I think it's necessary to go this deep sometimes to like really build good coding habits and to bring people's level of thinking of how to code and their code design thinking to the next level. And that's my goal for you, is to get to the next level with your coding and advance quickly on your journey, because there's so much to learn, and I want you to get there as fast as possible. So hopefully you like this video. If anything's difficult to understand, please let me know in the comments. ChatGPT is your friend. I have a Facebook group if you want to, be able to ask questions a little bit more directly with me. But of course, the comments are there too. And anyway, please subscribe so that you get a notification for the next video, and I hope to see you there. Thank you.